Good morning, students. Our today's topic is to find out the field due to an non-conducting charged solid sphere using Gauss theorem. As you know that we have discussing about Gauss theorem's applications. So this is one of the most important application of the Gauss theorem. So for this, let us consider a solid sphere like this of center O and radius say capital R. So now we have to find out the electric field due to this charged sphere. As it is a charged sphere, so whole of the volume is filled with the this say charge. So it is represented by a dotted lines, means it is a solid sphere filled with charge. Then say rho is the charge density of the sphere. Now we have to calculate the different positions, the electric field at different positions due to this charge sphere. Consider the case 1, that is we have to find out the field at a point inside this sphere, inside the sphere. Okay, so for this let us consider a point P like this, which is at a distance small r from the center O. Then imagine a Gaussian surface, that is an imaginary sphere with radius small r, such that point P lies at the surface of this sphere. So now consider a surface element on the surface around point P such that the direction of this area element is given by normal component, as electric field is also in the same direction as we stated earlier, mean there is no angle between electric field and surface area vector direction. So due to this, let us consider the charge between this region, that is the charge under the sphere, or we can say Gaussian surface is q dash, charge inside the sphere S, say it is sphere S. Okay, so now the electric flux is given by that is the surface integral of electric field E dot ds over the surface S. So as the angle between electric field and our component is the same, so the dot product gives the value as its magnitude, and this surface integral must be written as this surface integral E ds cos of 0, means we can write it as surface integral eds only. Okay, so it is equation first. Now we know that using Gauss theorem, the surface integral, that is E dot ds, must be equal to charge, that is q dash upon epsilon, where what is epsilon? It is the permittivity of the medium of the sphere. So E into this integral represents the surface area of the sphere, that is 4 pi r square, as r is the small r, 4 pi r square q dash upon epsilon. So the electric field must be written as q dash upon 4 pi epsilon r square. Okay, so it is equation second. Now we know that the volume charge density must be equal to the charge per unit volume. So volume of the sphere is 4 by 3 pi r cube. So we can write from here, that is q dash must be equal to 4 by 3 pi r cube into rho. Putting this value of q dash in equation say third, sorry, in the equation second, we get the electric field must be written as 4 by 3 pi r cube rho upon this 4 pi epsilon r square. So 4 pi is cancelled out, and similar is the r square is cancelled out, so electric field remains only, that is r rho upon 3 epsilon. This is equation number third. From the equation third, it is clear that electric field is directly proportional to r. So within increasing the distance from the center, electric field also increases. Okay. Now if we consider the second case, that is at the surface of sphere. Okay. Now when this point P is considered at the surface of the sphere, it means small r must be equal to capital R, that is r is equal to capital R. So we can write this equation number 3 is E must be equal to r rho upon 3 epsilon. So equation 4. Similarly, the third case, when point P is outside the sphere. So we already calculated in the previous article that this electric field must be equal to, or we can say inversely proportional to 1 by r square. So we can see from the equation fifth that the electric field is increasing as the distance is increasing from the center. It becomes maximum when the radius becomes equal to the radius of the charged sphere, that is r is equal to capital R. And outside the sphere, when we can say the distance is increases, electric field is decreases. So considering the equation third, fourth and fifth, we can draw a graph which show the variation of electric field with the distance from the center of sphere. Okay, if we consider electric field on y-axis and distance on r-axis, then if r is equal to 0, that is if r is equal to 0 in equation 3, then electric field becomes 0. It means at the center of sphere electric field is 0, and then it increases to a certain extent like this up to a distance r which is equal to capital R. Okay, then after capital R, if we further increase the distance, then electric field is decrease like this. Okay, so this part of the curve represent that electric field is inversely proportional to r square, and this part represent the electric field directionally proportional to r. So this is all about the electric field due to a charged solid sphere. Thank you very much.